Nitrogen atoms are essential atoms in biomolecules, contributing to the amino group in amino acids, for example, and the nitrogenous bases of DNA and RNA. When biomolecules undergo catabolism, when they are broken down for energy, very often the amino groups, the nitrogen atoms, are removed, which creates the problem. How do organisms then remove excess nitrogen atoms from their body, given that some forms, such as ammonia, are toxic? These nitrogenous wastes can be removed from blood at the kidneys and excreted from the body, but they can be excreted in different forms. Some animals perform ammontelism, excreting nitrogenous waste in the form of ammonia. This is especially common in fish and amphibians. The disadvantage is ammonia is highly toxic, and to excrete it, one needs a great deal of water, half a liter of water, to excrete a gram of nitrogen. However, if water is readily available, ammonia dissolves easily, and so animals which live in water might find this a useful way of excreting their nitrogenous waste, either in urine or even through gills and the skin. In some animals, ammonia is modified to form a different biomolecule, uric acid, and thus nitrogenous waste can be excreted in this form in reptiles and birds primarily. The advantage is that uric acid is less toxic than ammonia, and far less water is needed to excrete it, so it is a way of conserving water. This may have been especially important as the early reptiles needed to conserve water in their eggs as they were evolving eggs laid on land. In reptiles and birds, the uric acid can be combined with sodium and potassium ions in the cloaca, forming a solid waste so that the water can be reabsorbed. Finally, in ureotelism, the nitrogenous wastes are excreted in the form of urea as the liver converts ammonia into this less toxic molecule. It conserves water compared to ammontelism, requiring only about a tenth of the water to excrete urea, but it requires more water than uricotelism. It is also possible that a single organism utilize more than one of these forms of nitrogenous waste. So for example, fish such as lungfish, amphibians, and turtles may practice ammontelism in water, excreting their waste as ammonia, but uricotelism or ureotelism on land, excreting their nitrogenous waste in a form which is less toxic and which conserves water.